Hello guys, welcome back to the channel Jai Shri Krishna. So in today's video we are going to return count of prime numbers till n. So we will be given an integer n and we need to find out the number of prime numbers in the range from 1 to n. For example, if n equal to 6, then output will be 3 as if we check the range between 1 to 6, 2, 3 and 5 are the prime numbers. So prime number is a number that has only two distinct divisors, that is 1 and itself. So if we check 10, in the range of 1 and 10 there are 4 prime numbers 2, 3, 5, 7. So the approach that we can follow is first we can check if a number is a prime number or not. First we can implement the logic of prime number, and later in the second half what we can do is we can iterate the loop from 1 to n, and if a number is a prime number we can simply do count plus plus and we can return the count at the end. This is what it is expected for us to return the total number of count of the prime numbers occurring between that range. So if we check, firstly we have implemented is prime function where it is simply checking basically 1 0 1 2. These are not prime numbers. One is not prime number because uh, by definition prime number should have at least or at most two divisors, and one is the only divisor, so one is not a prime number. So we can simply return false, and here we are starting the loop from 2 to square root of n. So basically if we check like all the numbers up to square root of n and find no divisors, then n must be a prime number. uh, what we can do is uh, for example, if we consider n equal to 36, so the square root of 36 is 6, and we check numbers between 2 to 6, and if we in between, if we find any divisors, so basically that will be the divisor count will be more than 2, and hence we will find out that 36 is not a prime number. So what we are doing basically, we are iterating the loop from 2 to square root of n, and this is like the slightly optimized version of finding the prime number. And after that we are checking if n mod I is equal to 0, then we are returning false. This is you can consider this as each case. Okay, so after implementing this boolean function to check if a number is prime number or not, we move towards our next function, that is to check or to count the prime numbers till n. So what we are doing basically is we are iterating the loop from 2 to n, and in between this range we are checking because prime number starts with 2, so we are checking from 2 to n. If we encounter any prime number, then we will do simply count plus plus, and that is what is expected from us to return. So at last we will return the count of the prime numbers that is occurring between this range. So if we run the code, we can see it is evaluated and it is accepted. So once we submit the code, we can view the advanced analysis, and complexity analysis will be big O of square root of n plus big O of n into square root of n. Like this is running square root of n times and this is running n times. So we can say big O of square root of n. Like that complexity is this because each prime function has the complexity of square and it is called n times. So n into square root of n times, and space complexity is big of 1 as no additional space is required. So yeah, that's it for this video. See you in the next one. Until then, keep coding, keep exploring, keep smiling. Doodles!